Hello everyone, hope all are doing good. In this session, I want to discuss few problems on SystemVerilog which are very important for interview point of view. I just concentrating on basic topics of data types and arrays, queues for this. Coming sessions will discuss on OOPS concepts, randomization, constraints, coverage, etc. Okay, first question is declare a string data type code and the output of display should be I am learning system verilog data type. Okay, how can we write the program for the system verilog? You can write using the verilog also, but we have system verilog which is a advanced level which is used for test bench, right? So by using some of the system verilog constraints we can write the program. Okay, first program main. Program end program is a new model in the system Verilog. Whereas in Verilog we will use the module end module, right? But in system Verilog we can use the program end program but cannot be used at every time because the program end program has some disadvantage like when we are connecting the test bench to the design there will be race conditions. Okay, those race conditions can be observed clearly by taking a small example. Suppose you can take a small example like a non-blocking or blocking assignment. Okay, very simple example. Then you can see how the program is, when you use the program, how the error is getting because of that race condition. Okay, those things we'll see in the next session how the race condition is occurring. Okay, so here we have written program main program. Here we are not using any value, any any blocking or non-blocking assignment. We are not using anything. That's why the program will not make any problem. Otherwise the program will get the issue with the race condition. Okay, and initial begin string is declaring with a b c d. Okay, this is just what we can write in some model. If you want to write in some other model you can write like without taking string a b c d, directly in the display we can display that thing. Okay, but by using the string data type we can use like this. Okay, so a equal to I am and b equal to learning within the double quotations because the string should be declared in the double quotation, right? And c equal to sv, d equal to data type. According to our problem statement we can take accordingly. Okay, and dollar display, this is just for looking good. And dollar display percentile s is nothing but a format specifier which is used to display the string data type, right? We already know for decimal we have percentile d, for binary we have percentile b, for real number g, like that. For string s, a comma b comma c comma d, okay, within the concatenation, so that it will display the overall string. Okay, we'll see the result now. See what is the result? I am learning SV data type. As whatever they mentioned in the question, same thing we have generated. Right? So this is how we can write the simple system Verilog programming for data type. And coming to the question number 2, write a code to determine the length of the string. Okay, whatever we are taking the name, what is the length of the name? That means how many number of variable it has. A word, how many variable it has. Okay, just we need to take some string and we need to observe the length. Okay, so for that I have taken module string method is the name, string x, string y, initial begin, x equal to system, y equal to verilog. Okay, so dollar display length of x. I want to know what is the length of x. Okay, in system verilog we have the default methods, different type of methods we have for data types or arrays or dynamic arrays or associative arrays for mailbox, whatever, for everything we have the default methods, right? By using these predefined methods we can use length method len off is used to check the length of the string. Okay, so x dot len off, y dot len off. Okay, we can check the result. What is the result now? Okay, see what is the result here? Length of x equal to 6. Okay, 6 means SYSTEM, system means 6 letters. Okay, and length of y equal to 7. 7 is a Verilog. Okay, Verilog is a 7 letter. So length is 7. Okay, suppose if you see here, length of x equal to 6. Between these there is a much distance is there. Okay, suppose if you don't want that much of distance, that much of gap, so how can you avoid that gap? How can you reduce the gap? Means when you are using format specifier, you can put like this 0 or 1 2 3 like that width. Okay, 0 means minimum width, 1 means somewhat higher than the 0, 3 means like that, 4 like that. Suppose I am putting 0 and 5, so 0 will get some lesser width, 5 will get more distance. Okay, see if you observe, length of x equal to 6, 0 I have kept, so minimum distance, length of y equal to 7, the distance is more because of 5. Okay, so like that you can adjust the distance there. Okay, so this is the question number 2. Okay, coming to the question number 3. Replace the letter small s to capital S, small v to capital V, small t to capital T. How can we replace? Okay, suppose if you use the C language. Okay, in C language, how we'll write the program to convert the lowercase to uppercase? There will be ASCII value, right? For lowercase, we have the ASCII value, and for uppercase we have the ASCII value. The difference between lowercase and uppercase ASCII value is 32. I think so, right? So, uh, so by subtracting the 32 from the lower letter, we can convert into the uppercase letter, right? Vice versa. So, but here we no need to write those, we no need to do those conversions. Okay, directly we have the string methods here. Okay, converting to upper, converting to lower, we have the string methods in the system Verilog, right? So, if you see the program here, module string method string x, y, z, x equal to small s, I am taking y equal to small t, z equal to small v, as the question problem statement is given like that, right? So dollar display x dot to upper, whatever the data is there, whatever the string character is there in x, I want to convert into the uppercase. Okay, y dot to upper, z dot to upper, those things I have displayed here, right? So we'll see the result, what will be the result now here. Okay, converting to upper, converting to lower, we have the string methods in the system Verilog, right? So if you see the program here, module string method string x, y, z, x equal to small s, I am taking y equal to small t, z equal to small v, as the question problem statement is given like that, right? So dollar display x dot to upper, whatever the data is there, whatever the string character is there in x, I want to convert into the uppercase. Okay, y dot to upper, z dot to upper, those things I have displayed here, right? So we'll see the result, what will be the result now. So see, what is the result here? The small s has converted to capital S, small v converted to capital V, small t converted to capital T. Okay, so that is how we can write the program for converting lowercase to upper or uppercase to lower. If you want to convert upper to lower, just you need to write to upper. Sorry, to lower. If you want to convert upper to lower, then you need to put to lower. Okay. And coming to the fourth question, what is the question here? Code for queues. We already know the queue, right? So queue built-in methods. We have some built-in methods. Suppose if there is a queue, how we will send the data and how we'll retrieve the data by using the push and pop methods, right? So those methods we are going to use here. So methods like size, insert method, how we have to insert, where, in which position we have to insert the data, whatever the data we want to insert, which position we have to insert, like n by 2 position, nth position, n minus 1 position, and n by n position. Okay. And delete method, pop front method, pop back method, push front, push back. We know the difference between pop and push, right? Push is nothing but sending the data into the queue. Suppose this is the queue we have with the size n bit size. Okay, 5 bit. Suppose push front means I want to push front 5, then this 5 will be get into this first location. Okay, then again I am doing push 2. Okay, then this 5 will be sent to the second location, and this 2 will be placed here. That is the push front. Push back means from back onwards we can put the data into the locations. Okay, push back 6, like that. Suppose you want to do pop. Pop is nothing but retrieving the data, getting the data from the queue. Okay. Pop front means this 5 will get out, then this 2 will get out, and then 5 will get into the first location. If you do again pop front means, then this 5 will get out here too. Suppose if you're doing pop back, then whatever the data is there in the last location, that will be retrieved out. Okay, so these are the push and pop methods in the queue, right? So we need to satisfy all these conditions. What is the size? We need to insert in nth position, n by 2, n minus 1, n by n. We'll see those things first of all. Okay, first, how we have to create the queue here? How we can create in SystemVerilog means, module q, name of the module, integer a of index, we need to put dollar. That is the representation of q. For associative array we will put star, right, in index. So that is that representation. In queues we need to represent like this, a of dollar. Okay, in that we are assigning some values, 4 comma 2 comma 3. Okay, like that. Another queue I am taking, b of dollar equal to 8567. Okay, another integer j I am taking. J is nothing but like a nth position here. Okay, like a nth position I am considering here. Otherwise um, j is like a value here, whatever the insert value I want to insert somewhere. So whatever the j value is there, I can insert, or directly you can insert number also from the program. Okay, and integer pop a, pop b. That means whenever we are popping the data, we are assigning into the pop a, pop b, whatever we have retrieved the data. Okay, and initial begin a dot insert of 4 by 2 comma j. 4 by 2 means here total number of 4 locations are there, right? 4 by 2th location, and that means second location. Okay, uh, okay, first method, a dot insert of 4 by 2 comma j. 4 by 2 means what here? Like 2. 4 by 2 is nothing but 2, right? So in the second location we are inserting j value. Okay, what is the second location here? 4 is the 0th location, 2 is 1, 3 is the second. So in the place of 3 we are going to assign 4. Okay, we'll see in the result. Okay, so displaying a. And next one, insert a dot insert of 4 comma j. Okay, at fourth location, at fourth position we are inserting j. That means in place of 0 1 2 3 4, after 7 we will get the 4 in b. Sorry, a dot insert, right? So in insert at fourth location we will get 4. Okay, and dollar display we are doing, and a dot insert j minus 1. What is the value of j here? 4 minus 1 means 3. At third location we are putting 10. We are inserting 10. Okay, and displaying the value. A dot delete of 2. That means delete method. Whatever the data is there in the location 2, we are deleting that data. Okay, and dollar display of a dot push front 5. From front onwards we are pushing 5. That means in first location it will be 5. Okay, and A push back 20. From back onwards we are pushing 20. Last location the data will be 20. Okay, and pop A equal to A dot pop front. A dot pop front means what is there in the front? Already we push 5, right? So that 5 will be pop from the front. Okay, so that that value we are displaying. And pop B equal to B dot pop back off. Whatever the data is there in the back, we already sent the data 20 from the back, right? So we are popping the data 20. So we are displaying those things. Okay, so this is how we can do push front, push back, pop front, pop back, delete methods, inserting methods in the queue. Okay, so we'll see in the queue. Okay, we'll run the program now. Okay, see here. First, you have to check each display statement whether it is satisfying the condition or not. Okay, what is the value is there first? 4 to 3 in A. So we are adding, we are displaying 4 by 2 in the second position, right? What is there in the second position? 3. In place of 3, 4 came, right? Then 3 moved to the third location. So that is first one. Next, in fourth location, we are assigning 4. So in fourth location 4. Next j minus 1. J minus 1 means what? J is 4 minus 1 3. Third location we are putting 10. So here we are passing 10, right? So that is. Next delete of 2. Second location we are deleting here. So what is the second location here? 4 is the second location. Deleted 10 came to the second location. Next push front of 5. That means we are pushing front 5. Okay, 5 here if you see, and push back of 20, sending to the last location. Okay, next pop A, pop front 5 is retrieving. Then after retrieving, what is the data we have seen here? Next pop back and B, pop back of B dot pop back we are doing. What are the values out there? 8 5 6 7 in B. So pop back B means 7 is getting out. Okay, so 7 is getting out. Okay, did you understood how we are writing the program for Q? So if you have any doubts you can comment below, we can discuss the things. Okay, okay, coming to the fifth question. Code for array ordering methods like reverse, sort, or sort, shuffle. How can we write? Like if you see SystemVerilog, how we will write, how you will reverse the program in SystemVerilog. Suppose any like 1, 2, 3 is given, right? If you want to reverse to the value 3 to 1, first we need to check, get the reminder. Okay, reminder of 1 2 3, we need to perform the n mod 2 reminder, n mod 10, sorry. Then by using a reverse equal to reverse into 10 plus reminder, then we'll get the reverse value. Okay, by using the loop, by using the for loop or while loop, we can do that process, right? But in system verilog, no need to do all the things for reversing or sorting. We no need to do all the things. We have the predefined methods. Okay, we'll see now what are the methods we are using. See example, module array ordering. Okay, array int array of 9, size 9 we have taken and declared all the values, different values into the array. Okay, so what is the first method? Array dot reverse. When we use array dot reverse, automatically the array will got assigned. Okay, array dot sort, sorting means ascending order, like reverse sort, descending order, like that. Array dot shuffle method. Shuffle means combining, clumsy, shuffling. So that is how we can use the default methods. Okay, now we'll see what is the output. Okay, see if you see a dollar format specifier, we have used dollar p. Dollar p means for displaying total array. Okay, like a dim is decimal, like that, right? If you want to display total array, we have to use the dollar $p. Okay, so reversing the value, first what is the value we have taken? 572571431, like that. 134175, like that. Reverse sorting. Okay, 1 2 3 4 5 6 7, like that. Reverse sorting, higher to lower. And shuffling. Okay, so this is how we can use the array methods. Okay, these are very basic things we have discussed, the starting concepts. So once we move some other concepts, you will get the things how we will write for object oriented programming and all. Okay, so if you have any doubts, please comment below, we'll answer your doubts. And if you are looking for advanced VLSI design verification course, which is a job oriented course in VLSI domain, you can contact the semi design. Okay, so for more videos, please subscribe, like, and please share to your friends. Thank you.